So the first step in our analysis is going to be to explore the CSV file that the client has presented us with. Now keep in mind there is a time constraint in trying to get this model out to the client as soon as possible so they can present candidates with offers based off of our model. So unfortunately, we don't have the opportunity to go back and forth with the client to get information that might help us in making a more accurate model. So unfortunately, these are the fields that we are provided that we will have to make our model from. And we can see here that we have the employee ID number. We have the position that the employee was hired for. So of course, we would expect that each of these rows is a data scientist, since that's the position that we're trying to create a model to predict the salary for. We have the months of experience, which is the number of months that employee had prior to being made an offer by this company. And then we have the salary that the employee was offered. So from here, we can try to understand if there's any relationship between our months of experience and the salary that was offered. And we want to create a model that's very much in line with what's been offered in the past, but also create some fairness and some guidelines going forward that a recruiter or someone who's in the position to make an offer to a candidate can simply enter the number of months of experience that candidate has, and they'll only return back one value for salary that candidate should be offered. So using this information, we're going to quickly import this into Tableau and perform a bit of exploratory data analysis. Now, prior to doing so, we just want to quickly look through the data and ensure that we have integrity for all fields. And what that means is just making sure that the positions, that there's no naming differences between data scientists, that we have employee ID numbers for each, and that there is no null information or information that would potentially pose an issue for a model. So doing just a quick scan, it looks like everything seems to be in line. So let's go ahead and save this file and pull it into Tableau to perform a bit more of an analysis. Now that we have the opportunity to explore the CSV file directly with the client, we'll now open Tableau and import the position salary CSV. As we can see, we have each of the columns below, and we'll now navigate to Sheet 1 and begin performing exploratory data analysis on position salary. We'll create a scatter plot with our y-axes of salaries and our x-axes of months of experience, and we'll deaggregate the view by dragging employee ID onto details. Now each dot here represents an employee ID, the number of months that they were employed prior to receiving an offer, and the salary of the offer that they received. And we can see here visually that there seems to be a relationship between salary and months of experience. In some cases that relationship seems linear, in other cases it seems to be an exponential relationship. Now, using a few of the built-in features that Tableau has to offer, we'll now drag in trend lines and we'll explore a linear trend line and how it fits this data. So we can see here that the linear trend line seems to fit the data relatively well between 8 and 12 months, but in most cases it seems to underfit, and in other cases it seems to overpredict. By hovering over the trend line, we can see the equation itself, as well as the R-squared value of 0.90. And what this means is that 90% of the variability in salary can be attributed to by months of experience. So now we'll view an exponential trend line, and we can see visually that the exponential trend line seems to fit our data better than the linear trend line. And by looking at the R-squared value, we can see that we have a value of 0.96. So again, we're getting closer to 1, which would be a perfect fit. Lastly, we can explore a polynomial regression line, and we'll navigate back over the trend lines and drag on polynomial. And visually, we can see that this is by far the best fitting line. And by hovering over, we can see the R-squared value of 0.99, which is a near perfect fit. And if we right-click on the trend line and we click on Describe Trend Line, we can see the equation and all the coefficients associated with the trend line. And we'll come back to this equation because this will be used in order to predict salary from a value that the user enters by a parameter. So now what we want to do is create the interactivity. So create a ability for the user or stakeholder to enter a value, which would be the months of experience of the candidate, in order to predict the salary. So we'll right click on create parameter. We'll call this candidate months, and we'll make sure the data type is float so they can enter decimals, and we'll show the parameter. Now we'll navigate back over to the CSV file. And we're going to create a dummy record, and essentially this will be an employee ID that has the ID of user, had a role of data scientist, they were employed previously for 1 month, and their salary that they were offered was $1. And we'll save the CSV, and we'll navigate back over to Tableau, and now we'll just refresh our data source. And you can see at the bottom left, we now have employee ID equal to user. And now we'll create a calculated field so that we can identify this in the scatter plot. So we'll call this color, and we'll say where employee ID is equal to user, and this will create a Boolean field. And we'll drag the Boolean field onto color, and you can see here our original data points are colored in blue, and our user, which is our dummy field, is now in orange. And if we right-click on the blue polynomial trend line, we can now copy and paste this equation directly into a calculation. So we're going to right click and create a new calculated field, and we're going to call this field salary1, and this is going to be equal to, if the employee ID is equal to user, which means they're the dummy record, then we're going to use this formula to predict their salary. Otherwise, this is a legitimate record in our data source, at which point we want to return back the salary of that employee. Now, in the equation, anytime that we see months experience, we want to replace this with the parameter candidate months. And this allows this formula to recalculate based on the value that is entered into the candidate months parameter. And then we'll click OK. And we'll create a new field very similar, and we'll call it months experience 1. And same logical statements. So if the employee ID is equal to user, then we'll return back the candidate months. Otherwise, we'll return back the months of experience. And OK. Okay, so we'll clear the view just because we have to reconstruct this scatter plot using our new fields. And so the y-axis will now be salary 1, the x-axis will now be months experience 1. We'll drag employee ID onto details to deaggregate, and we'll drag color onto color. And now we will enable the parameter, and we'll hide the color legend. And we'll navigate back up to analytics, and we'll drag on the polynomial regression line. And we can see here it's calculated twice, so we'll go ahead and edit the trend line, and we'll disable the feature to allow it to recalculate based on each color. And now what we can see here is the orange dot now represents the salary based on the number of months that the user enters into the candidate months parameter. And using this formula, it will predict a salary or return a salary on this line, regardless of what value is entered. And we can actually go beyond the scope of our data. So I think our max months of experience based on our data is 38 months, but we can actually go beyond that, and you can see that the relationship remains consistent and that the equation remains consistent. So this is one way of creating an interactive dashboard that references a polynomial regression line that's been created within Tableau. So after showing our client our predictive model that we developed, they mentioned that there's an additional Excel file that they recently received that has additional employees that they want to have the model recalculated to reflect. So here we have a list of employee IDs. Again, similar structure, but new months of experience and new salary amounts. And what we discover is that the data is actually going to be added iteratively from different departments. So as we navigate back into Tableau, we can recall that our polynomial regression line, we've essentially used this equation within our salary1 formula, which is being used to predict the salary based on the candidate months that we enter into the parameter. Now, the issue here is that as new data is added, this line will have to be recalculated, which means the coefficients of the line are subject to change as well as the y-intercept. So what we'll do is copy the new data that the client has provided into our original Excel spreadsheet. We'll save it. We'll now navigate back over to Tableau and refresh our data. And as you can see, new dots have appeared, which has changed the line of our polynomial regression line. Now, if we enter different months, we can see that we are relatively close still to the output predicted by our polynomial regression line, but we are slightly off in some cases, and because we are trying to create a model that takes into account fairness, we have to ensure that this polynomial regression line, that the values that we calculate are on the line itself. Now, as we hover over the line and we compare it back to the formula used in salary 1, we can see here that the equation for salary 1 of the current polynomial line is different than that used in salary 1 of our equation. So we'll hover over and click on describe trend line, and we'll copy the new equation and we'll paste it right below. We can see the differences. Not drastic, but again, there are differences that will lead to different outcomes. So we'll update our formula or our equation below, and we'll delete the original polynomial trend line equation, and now we'll click OK. And we can see here that the orange dot now, it will now reflect any value on our new polynomial line. Now the issue here is that as new data is added, we'll have to continue to go through this process of recalculating how salary 1 is being computed. And unfortunately this won't be a simple process, especially given that the idea is to hand this over to the client and have them take the ownership of this process going forward. So we don't want to hand over a process that's going to require a user to go in and make manual updates. So what we have to do is design a solution that will take this into account automatically. So what we'll choose to do is integrate R into our ETL process. So we'll go ahead and open RStudio and we'll create a new R script. And we'll load the original CSV file that the client had provided us, which is position salary. And the purpose of using R is essentially to migrate the model from Tableau, which was a static model which referenced coefficients within the salary 1 calculation. And we'll migrate the model into R to just create an additional layer of ETL. So we'll go ahead and take a look at the salary CSV file that we loaded, and we can see here, looking at the first 20 records, that the file did in fact load correctly. And we can see the employee ID, their position, months of experience, and salary. Now, given that we know the visual that we want to create within Tableau, which reference only months of experience and salary, we can remove any fields that are sensitive or unnecessary. So in this case, the employee ID as well as the position, since our analysis within Tableau doesn't require those fields. And again, this would be sensitive information that we would be holding on to. So what we'll create is a keep list, which essentially has the fields that we want to retain within our data frame. And the next statement here is essentially just going to compare all of the fields that we have within our data frame, which is our CSV file, and it's going to compare it to our keep list and essentially only retain those fields within the keep list. And so we'll now look at the structure of our data frame, and we can see below that we've only retained the 2 fields that will be necessary going forward in our analysis. So one of the benefits of actually using Tableau first in the exploratory data analysis process is that we've already concluded that the polynomial regression line fit our data the best. So within R, we're just going to reconstruct those polynomial terms. And within our data frame, which is our position salary CSV, we're going to add additional columns, which is essentially going to just take the months of experience and raise them to different powers. So our months experience 2 is going to take our months of experience and raise it to the 2nd power. And we're going to go ahead and copy this first statement, and we're going to paste it 2 additional times. And we're going to raise our months of experience to the 3rd and to the 4th power. And we'll take a look at Tableau, and we'll look at the polynomial trend line, and we'll click on Describe Trends. And if we look at the coefficients, we can see here that this is exactly what Tableau has done. It's taken the months of experience and it's raised it to various powers, from the 1st power all the way to the 3rd power. So within R, we'll take our months of experience and we'll raise it all the way to the 5th power, so essentially creating 4 additional columns onto our original data frame. And we'll go ahead and run this statement. And the next step is going to actually be to create the polynomial model itself. So again, a polynomial model is just a linear model where our y variable, or response variable, is salary. And we're going to take all of the terms that are on our data frame, so each of the polynomial terms, which is represented by the period. So this would be the equivalent of writing out each of the terms independently. So we could say months of experience plus months of experience 2 plus months of experience 3, all the way up to months of experience 5. But this can essentially just be replaced by a period, which will reference all of the fields that are contained within this data frame. And so we'll go ahead and run this model here, which is our poly model. And we'll look at the statistics on the poly model itself by running the summary. And we can see, similar to Tableau, we have our coefficients, but we have a bit more information. We can see our degrees of freedom as well as our adjusted R squared, which in this case is 0.9907. So we can take this value and we can go back to Tableau and we can recall the R squared here, which is 0.9905. And we can see that our R squared within R is marginally better, and that's likely as a result of introducing 2 additional polynomial terms. And we can take a look at the structure of our data frame, and we can see here that we have our 2 original columns, which are months of experience and salary, and we have the additional polynomial terms, which is essentially just taking our months of experience and raising it to various powers. Now that the model has been developed, there isn't a need to hold on to these additional polynomial terms within the data frame itself. So they were necessary for our model, but they're not going to be necessary once we import this data into Tableau. Because again, we're just creating our scatter plot based on the months of experience, as well as our salary field. So we're going to run this clause again, which is just going to restrict our data frame to only include those columns within the keep list, which would be months of experience and salary. And we can see here that we have the same number of observations as before, but with only 2 variables. So the last step within R is going to be to run our polynomial model against simulated data. So it's important to remember that for months of experience contained within the CSV file, we didn't have a value for every month ranging from 0 to 39, which was the max value for months of experience. So we're going to have to simulate what those values would have been for predicted salary. So we have an object that's called xsim, which is the sequence of values between 0 and the max months of experience within the data frame, which is 39. And it's in increments of 0.1. So if we look at our xsim, we can see here that we have values starting from 0 all the way up to 39 in increments of 0.1. We'll then create an object called simData, and we're essentially going to use our xsim, which is values from 0 to 39 in increments of 0.1, and we're now going to compute our polynomial terms using the xsim data. So months of experience will be equal to xsim, and then we can go ahead and copy and paste this statement 4 additional times. And we're going to update months of experience to 1, 2, 3, 4, and 5, and we're going to then raise our xsim accordingly to the corresponding power. And this is essentially representing our polynomial terms that we had within our data frame, where we were taking the months of experience and raising them to various powers. We're now taking these values ranging from 0.01 or 0.1 to 39, and we're raising them to various powers and essentially creating these new fields within our data frame called simData that mimic our polynomial terms. And so now what we're going to do is create a new object called simSalary, and we're going to, using our polynomial model, we're going to predict what the salary is for each of these simulated fields that we just created within our simData. So now if we take a look at simSalary, we can see here that this is the predicted salary based on each of our records that we had within our simData frame, which again was from our simulated numbers ranging from 0.1 to 39 in increments of 0.1. And we're going to take this predicted output, which is our salary for each of these values, and we're now going to add it back to our sim data as a field called salary. And we'll look at our sim data, and you can see here we have the months of experience ranging from 0 to 39, and we have the salary on the very far right, which is our predicted salary based on that number of months of experience. And on this data frame, we're going to create a new column called sim data, and we're going to update this to 1. And this is essentially saying that every single record that is on this data frame was in fact simulated, so these aren't values contained within our underlying data, that we essentially had simulated what these numbers would have been. Similar to what we did above, we're only going to retain the relevant fields on our sim data data frame, and those fields would be months experience, salary, as well as our sim data field. So this is going to be important within Tableau because we are going to have to differentiate what was real data that was provided to us in the CSV and what was simulated data that we essentially ran through a polynomial model. And so we're now going to restrict all of the fields within our sim data frame to only reflect months experience, salary, and sim data. Okay, and then lastly, we'll take a look at our sim data frame. And we can see here we have 391 observations with only with only 3 columns. All right, so what we'll do is we'll scroll above and we'll take a look at our data frame, which was our CSV file that was provided to us by the client. And we can see here we have our months of experience, our salary, and each of the polynomial terms. So we want to create this data frame to resemble the same structure as our sim data. So again, only containing 3 columns. So what we'll do is because we've created this above, we'll essentially look at the structure of our data frame. And we can see here that we have 6 fields, so months experience, salary, and then each of the polynomial terms. And we'll navigate above and we'll essentially just copy one of our keep lists that we had created before. Since as of right now, these are the only fields relevant on this data frame that we want to retain. And we'll go ahead and run this. And then we'll take a look at the structure of the data frame itself, and we can see here we only have 2 columns. But we do need to include a new column on this data frame, which is called sim data. And similar to our simulated data frame, with the exception that our sim data field is going to be updated to 0 because this isn't simulated data. This is data that was provided to us by the client. So now we'll take a look at the structure of our data frame, and we can see here that we have 3 fields, months of experience, salary, and sim data. And the last and final step is essentially going to be to union these 2 data sources together. So we'll create a new data object called salary data. And here we'll union the data frame to the simulated data. So this is our client data to the data that we created within R that essentially resembles each of the X values that wasn't contained within our original data frame. And now we can take a look at the data frame that we just created, which is our salary data, and we can see below that we have 441 observations. So again, 390 of those came from the simulated data and 50 came directly from the CSV file that the client had provided us. And the last step is going to be to write this data frame, which is our salary data, as a CSV file so that we can import this into Tableau. Now that we saved our data as a CSV file, we can now navigate back to Tableau, create a new sheet, and import the CSV file that we just created within R. Now looking at our data, we can see that we have 4 columns. Although only 3 were outputted, R has a tendency to output the index as well as column F1. So we'll go ahead and rename that to the index, and that will be used similar to how we were previously using the employee ID as a unique identifier. So we'll navigate back to sheet 2, and we'll drag the index up to dimensions as well as the sim data, which identifies if it was simulated or if it's data directly from our CSV. And we'll create 2 parameters, and the first parameter that we'll create is going to be called months experience. And the second parameter is going to be days. So we're going to allow the user to enter the number of months as well as the number of days that a candidate has to predict the salary that the candidate should receive. So we're now going to create a new calculated field and call this candidate experience. And in this calculated field, we're going to take the months of experience that the user enters by the parameter, and we're going to take the days that they enter as well and divide it by 30 to get a decimal. Now it's important to remember that based on our R logic that we had created before, our R script, we only have increments of 0.1 from 1 all the way to 38 within our data. So therefore we have to round this to 1 decimal place. The next step is going to be to construct our scatter plot using salary as the y-axis and months experience as the x-axis. And we'll use index to deaggregate. And we can see here that we now have what resembles very similar to sheet 1, which is our polynomial regression line as well as our scatter plot. Next up is going to be create a calculated field that's called size. And we're going to use this to differentiate between our polynomial line, our data points, as well as the user entered months of experience. So we're going to see if months experience is equal to the candidate experience, then 10, which is going to return back a size of 10. Otherwise, if it is in fact simulated data, which means it's representing our polynomial trend line, then 0.25, otherwise return 3. So we have 3 different sizes that this calculation is returning, and we're going to drag this onto size. The next calculation that we're going to create is going to be color, and this is going to help us to differentiate between the data points, the polynomial line, as well as the user entered months of experience. So we're now going to say if months of experience is equal to candidate experience, then 1. Else if sim data is equal to 1, then 2. Otherwise, 3. And so we're essentially just differentiating between our different types of data, so simulated data, non-simulated data, as well as user-entered data. And we can see here when dragging color onto color, we now can differentiate between the data points within our CSV file, which are in red, the orange points, which are our polynomial line, as well as the blue point, which is our user-entered parameter. So we've now given the user the ability to enter different months and different days, and we can see here that the blue line will continue to change as the user enters different months and different days. So we will continue to predict the value or return back a value on the polynomial trend line. And you can see here that the user can enter months and days separately into the parameter. Now what we're going to do is create labels, and these labels will essentially help us better understand exactly what the salary is that the candidate should receive based on the location of the blue dot. So we're going to create 4 labels, and the first label is going to be months experience label, and this is if the candidate experience is equal to months experience, which essentially means if it is that blue dot, then we're going to return back this string which is months experience. And this will be our first part within creating the label itself. Otherwise, we're going to return back null. So if it's not a value that's associated with the blue dot, so if it's associated with the red dot, return back null. Otherwise, return back months experience. And then we're going to create the second part of this calculation. And the reason that we're creating this as 2 separate parts is we want to be able to retain the numeric value associated with months experience and not necessarily convert that into a string. So now we're going to say if candidate experience is equal to month's experience. So again, if it is the blue dot, then return back month's experience, otherwise null. Now we'll create two identical calculations, except this will be for salary. And so the first calculation is going to be, again, we need to identify the blue dot. So if candidate experience is equal to month's experience, then return back the string salary. Otherwise, return back null. And the last calculation for the label is going to be salary label 2. And this is going to have the same logical statement. So again, we're trying to identify the blue dot. And the exception here is that we're just going to return back salary. So if candidate experience equals month's experience, then salary, else null. Now using these four labels that we just created, we're now going to drag them onto the label mark within the view. And the order doesn't matter right now in terms of how they're dragged on, because we will restructure this inside of the labels mark. So now we'll click on the labels mark and navigate to text, and we'll go ahead and delete the structure here because we can quickly reference it. And we'll add the month's expected label, which again is just a string that returns back month's experience for only the blue dot. And then we'll return back the corresponding value for month's experience. And then we'll enter the salary label, which again will only return back salary for the blue dot, as well as salary label 2, which will return back the numeric value. And then in order for this to work, we'll have to allow labels to overlap. And then we can play around with the formatting itself. So we can center it, left justify, make the font bigger, more legible. So just for the purposes of this demonstration, we'll make the size a bit bigger so it is legible. And we'll make it a similar color to the dot itself. And now what we can do is we can enter different months and different days, and this value will recalculate. And you can see here that our month's experience is updating accordingly, and our salary is also updating accordingly. Now, it's important to remember that we can change, because we retain the salary label 2 as a numeric value, we can actually reformat this into a dollar, as opposed to if it was a string value, we would have to then enter the dollar symbol into the string itself within the calculation. So just to demonstrate that this works with all values, we can see here that now this gives the user a good insight into what the salary should be based on the months of experience. And they can change the months and they can change the days to get more granular, as opposed to previously only having the ability to change the months. Now, one thing to note, if you look at these orange dots here, these represent the polynomial trend line, and we'll go ahead and remove the tooltip. Now, these dots are in increments of 0.1, so you can see that there is spacing between. So we'll navigate back to R, and these dots are essentially being created by this statement here, which is the xsim, which is the sequence from 0 to max df. And we'll go ahead and increase this from 0.1 to 0.01. So it's essentially going to create more records within our data model. And we'll go ahead and quickly run this, and we'll navigate back over to Tableau. And we'll quickly refresh our data. And what you can see here is now the line looks a bit more filled. And the reason being is that we were able to input a number of additional x values. And so this allows us, instead of having our days divided by 30 round 1, we can now round to 2 because we are holding 2 decimal places in our data set. And now we have just created a tool that we can now present to the client, which gives them the flexibility to add months of experience and days and return back the expected salary that they should be offering the candidate based on historical data.